today's video is going to be about adding, subtracting, multiplying, and dividing polynomials. So we're going to start with addition and subtraction. So when we're adding or subtracting two polynomials, here are the key things that you need to know. So the first thing you do is you need to make sure that you're combining like terms. And what that means is you're combining terms that have the same degree. So if I have an x to the fifth, I can only combine that with other x to the fifth terms, and so on and so forth. So the first thing you need to do is combine like terms. The second thing that you need to do is once you've combined all your terms, you need to reorder your polynomial. So reorder your polynomial in what we call standard form. Okay, so what standard form is if I have a polynomial, I write my terms in descending order from the highest degree to the lowest degree. So an example would be if I have 3x to the fifth plus 2x cubed minus 5, this polynomial is written in standard form because I went from highest degree to lowest degree. So you want to go in descending order. Okay, so now that we've kind of gone through the basics of adding and subtracting, now I want to do a couple of examples. Okay, so let's take a look at our first example where I have two polynomials and I'm going to add them together. So our first step is to combine like terms. Now, if my students are watching this, they know what I'm about to do. I love color coding things. So I'm going to color code all the terms that are the same and that I can actually combine. So I have a 3x cubed term. I have a negative 4x cubed term. Those are all my x cubes. Now I have a negative 5x term. I have a positive 2x term, so those can get added together. And then it looks like here I have a constant term of 13 and a constant term of 1. And then it looks like we have this lonely 2x to the 7th. There's no other x to the 7th terms, so that guy is going to stay by itself. We can't combine it with anything. Okay, so let's combine these two polynomials. So I have 3x cubed plus a negative 4x cubed. Now remember, I'm adding a negative, so it's kind of like subtracting. So I'm going to order these. So I'm doing 3x cubed plus a negative 4x cubed, which is minus 4x cubed. Okay, now let's see, I have a negative 5x and a 2x, so I'm going to actually leave this as minus 5x plus 2x. And then I have a 13 plus 1. And then I have that lonely 2x to the 7th. Okay, so now I can actually combine these things. If I have 3x cubes and I subtract 4x cubes from it, I'm left with negative x cubed. I have negative 5x plus 2x, so then I am left with a negative 3x. And then I have 13 plus 1, so then plus 14. And then this guy just hangs out because he doesn't have anything to combine with. So it's just 2x to the 7th. Now my last step to give a final answer is to rewrite this in standard form. So I need to take my highest degree, which is that 2x to the 7th, that goes in front, and then I'm just going to order these in descending order. So that means I have 2x to the 7th, minus x cubed is my next largest, minus 3x plus 14. Okay, so this example is really similar. Instead of adding two polynomials, I'm now going to subtract them. So I have x to the fifth minus 3x cubed plus 5x minus 1, notice they're in parentheses, minus 3x cubed plus x to the fifth minus 7. So I'm going to do the same thing where I'm going through each of these terms and I'm going to color code the ones that are actually like terms and can be combined. So then I have x to the fifth term. Looks like I have another x to the fifth term here. I have a minus 3x cubed term here. So x cubed term here, 3x cubed term here. And then I have a x term. It looks like that x term's lonely. There's no other x term to combine it with. And then finally, I have these constant terms. So I have a minus 1 and a minus 7. Now here is the part that everyone seems to forget, or this is the biggest mistake that I encounter. When you're subtracting all of these things, you need to remember to distribute that minus sign all the way through. So actually, before I combine, I'm gonna actually distribute this minus sign through these terms. So that way it's a lot easier for me to combine and not forget that I'm subtracting all of those terms. Okay, so I'm gonna rewrite this as x to the fifth minus 3x cubed plus 5x minus 1 minus, I'm distributing that negative, 3x cubed minus x to the fifth, and then minus a negative 7 is a plus 7. Okay, so now I just need to take all these terms and combine them. So my x to the fifth and an x to the fifth. So I'm going to reorder. So I have x to the fifth minus, this x to the fifth. Okay, and then I have this minus 3x cubed, and then minus another 3x cubed. I'm just reordering so all my like terms are together. And then I have this plus 5x. I don't have any other x's to combine with that one. Okay, then I have a minus 1, and then a plus 7. Okay, so now let's just combine these terms. X to the fifth minus x to the fifth is 0, so I don't need to write anything for that. Negative 3x cubed minus 3x cubed is going to be negative 6x cubed. And then I have this plus 5x. There was nothing to combine that with. And then I have a negative 1 plus 7, so that's going to be plus 6. And I didn't really do this 100% on purpose, but maybe subconsciously, I kind of reordered this step so that all my terms were in that standard form order. So I actually don't need to reorder my final answer down here because it's already in descending order from highest degree to lowest degree. Okay, so now we're going to talk about multiplying polynomials. Now, multiplying polynomials is really just using the distributive property a lot. And so you have to make sure that you're multiplying each term in the first polynomial by each term in the second. So let's go over what I mean by that. So your step 1 is to distribute a lot of teachers call this FOIL when you're multiplying binomials. That's probably the most common time that you've seen this before this course. Or FOIL. And FOIL just stands for first, outside, inside, last. And that's just a nice little mantra to help you remember the distributive property for multiplying binomials. You multiply the first terms together, then the outside terms, then the inside terms, then the last. And then number 2, same actually as our step from the last lesson with adding and subtracting, is just to rewrite your polynomial in standard form. Okay, so now I'm going to do a couple examples of these so you can see what it looks like with what we're used to with multiplying binomials and using FOIL, and then maybe working with some larger polynomials that we're going to multiply together. The distribution gets a little bit trickier with those. Okay, so our first example should look pretty familiar. This is just a standard multiplying binomials problem. So we're going to use FOIL. Our F stands for first, so I'm going to multiply my first terms together. So this equals x times 3x. Okay. Then I'm going to add that to my outside, that's what the O stands for, my outside two terms. Multiply those together and add them. So we have x times -2. Then I have my I in FOIL. Those are my inside terms that I'm going to multiply together. So it's going to be plus 5 times 3x. And then finally, I'm going to add that to my last terms. That's what our L stands for, last terms multiplied together. So I have 5 times -2. Okay, so now I just need to kind of clean this up, simplify it, combine like terms, and make sure my final answer is written in standard form. So x times 3x is 3x squared. Then I have x times -2, which is -2x. We have 5 times 3x, which is 15x. And then I have 5 times -2, so that's a -10. Now I'm going to combine these like terms. Those are the only ones I can combine at this time. So then this equals 3x squared plus -2x plus 15x is 13x minus 10. Okay, now we're going to move on to an example that's a little bit trickier than this. Maybe we'll do a trinomial and a binomial, so that way you could see this distribution on something a little bit more complex. Okay, so now we're multiplying a binomial by a trinomial. So I just have a little bit extra distribution to do. So first I'm going to take my w plus 3. I'm going to make sure that each term in my first polynomial gets multiplied by each term in my second polynomial. My first polynomial is w plus 3, and my second polynomial is w cubed minus 4w plus 1. So first I'm going to distribute my first term, so w times w cubed plus, we're going to distribute that same w to now -4w. Okay, plus, so if you can see, we're going to do this 6 times. W is now going to get distributed to that 1. Okay, plus, keep going. Now we're taking our 3 and we're going to distribute to each of these terms. So 3 times w cubed. Okay, plus, and hopefully I have enough room. I need to move these. Let's see, what haven't I used? Red. So 3 is getting distributed to now -4w. Okay, and I almost ran out of room, but finally our very last term looks so pretty. It looks like a rainbow. Okay, and then it's 3 times 1. So plus 3 times 1. Okay, you can kind of see that, right? Had to squeeze that one in there. Okay, so now I'm going to just clean this up and then reorder it and put it in standard form. So w times w is w times w cubed is w to the fourth. W to the fourth. Plus, well, I'm not going to write that as plus yet because I see this negative here. I have negative 4w times w, so that's a negative 4w squared. Then I have w times 1, which is just w. Then I have plus 3w cubed. And then I have a 3 times negative 4w, so that's a negative 12w. And then finally plus 3 times 1, which is just 3. Okay, so now let's reorder this. Add my equal signs in here. So w to the fourth. My next smallest term is 3w cubed. I don't have any other cube terms in here to combine that with, so it's just going to be plus 3w cubed. Now I have this minus 4w squared. I'm looking around. I don't have any other w squareds to combine that with. Okay. And then I have a w and then a minus 12w. So then I have minus 11w. I just combined these terms. W minus 12w is negative 11w. And then plus 3 because that's my only constant term. So I have written this in standard form. You can see I went from descending order, w to the fourth, all the way down to my constant term. And I cleaned it up a bit by combining my like terms and multiplying everything through. All right, so now we're moving on to dividing polynomials, but specifically by monomials. We're not going to get into the heavier polynomial long division and synthetic division quite yet. We're just going to kind of go over the basics of if I have a string of monomials that are added together, in other words, a polynomial, and I divide it by a monomial, how do I handle that? So what you do is, first, you divide each term individually in the numerator. By the denominator. So the denominator is just going to be some monomial, and we'll go over some examples of what that would look like. And then finally, you're just going to write your answer in standard form. And then one thing that I'd kind of like you to start doing is to rewrite any negative exponents as positive exponents. So rewrite negative exponents. And an example of what I mean by that is if, let's say, I had 3x to the negative 2, then I just rewrite this as 3 over x squared. Okay. All right, so we're going to run through a couple of examples of taking a polynomial and dividing it by a monomial. So here we have 4x cubed minus 7x plus 1 all over x to the fourth. So the first thing that I talked you through doing is taking each individual term in the numerator and dividing it by the denominator. So this equals 4x cubed over x to the fourth minus 7x over x to the fourth plus 1 over x to the fourth. Now I'm going to clean this up a little bit because x cubed over x to the fourth, when we're dividing exponents with the same base, we subtract. So 3 minus 4 would be x to the negative 1. Or you could even think of it as 3 x's in the numerator are going to get canceled out by 3 in the denominator. So I'm just going to be left with 4 over x. Okay, so minus, same idea here. X to the fourth is x times x times x times x. one of those x's is going to get canceled out with the numerator. So then I'm just left with 7 over x cubed. And then this 1 over x to the 4th just stays as is. And this would be my final answer for this one. There's really no more cleaning up than that, because you end up with actually a bunch of negative exponents and they're already rewritten as positive exponents. Okay, number 2. This one's slightly different. So I have 2x to the 5th minus x plus 1 all over 3xy. So I'm going to do the same thing where I'm going to take each term in the numerator and I'm going to divide it by the denominator. So I have 2x to the 5th over 3xy minus x over 3xy plus 1 over 3xy. I'm going to do a little bit of cleaning up here. So x to the 5th over x, what I'm actually just left with is 2x to the 4th over 3y. That 2/3 I can't reduce at all. And also there's no other y's in my numerator to do any cancellation with that y, so it's just staying as is. Minus x over x is 1. So I end up with just 1 over 3y. And then this 1 over 3xy I can't really do much else with to clean up, so it's just plus 1 over 3xy. And you could, if you want to, combine this term since their numerators are their denominators are the same, but I'm fine with you leaving them.